In this content, you will learn how you can build Qt applications for Raspberry Pi and Jetson boards. This is called a cross-development, cross-applications, cross-development, because the hardwares are different, right? I explained these things before. If you haven't watched the previous tutorials, I recommend you to watch them. And they explain also, if you watch all of them, you can understand how I come up here, how come I came with this idea that I am going to explain it again. There's also one video before that I did, which explains with the Docker again. So you can watch them also. I am going to explain quite the same things in this tutorial, but I change a little bit. So the idea is same, but there are some details. The details are different, some details. So I also explain you how you can use this idea for the Jetson boards. This is quite same. If you check on the internet, for example, how you just search Qt for Raspberry Pi or something, you can find some kind of a tutorial, some step-by-step tutorials from a Qt web page. But I think this is not a correct way. So I use this way too. This is just you have to build Raspberry Pi yourself. You need to boot it up, and you need to update the software, and you need to copy kind of the sysroot to your host environment, and you need to have correct toolchain. You need to understand these things. Otherwise, if you have all this cool toolchain, or the toolchain is not suitable for your environment, then you will have kind of problems that it's so hard to understand. It's kind of torturing for you. If you don't know what is going on, this is not a good way. The explanation is missing here. It's not complete, because dependencies are important in this case. Qt has a hardware dependencies for touchscreen, for graphic operations. There are a lot. And if you don't know these dependencies, how you handle, then the things will be bad for you. There is also another way that I checked with this kind of, I don't know, like what it's called. This is Qt setup. I don't know, like a installation wizard or something. What is this? There's also another way that I saw on the internet. They provide a kind of a tool, Qt Creator and Design Studio. I don't know what is this, Qt Online Installer, that you can install this and it will help you to install Qt for Raspberry Pi. But still, in this case, you need to boot Raspberry Pi with their Qt software stack. So they provide an image for you. I mean, I don't want someone create an image for you. I want just Qt binaries. This should be very simple. So you can use these things for development, but I'm not sure these are good for continuous development. Even if for development, for me, it's not a good idea. So the idea is like what has been done before, also what I was doing before. So first, I have a target like a Raspberry Pi or my target ARM environment. Most of the time it is ARM, and you just simply update this, and bring in a level that you have all the dependencies inside, and be sure that everything is updated with this target, and get all this dependencies like under the USR directory, the binaries. Get these binaries to your host environment. Copy them all. Like there are a lot of symbolic links, these kind of things also there exist, and you need to fix them. And you need to have the toolchain, correct toolchain. You need to check on a target which toolchain, which GCC version it has. Then you need to install it on your host. At this point, the operating system, it can be important, because also you need to compile the toolchain, and there are also dependencies. So this is getting harder and harder. Then you need to build Qt on your host, and you need to cross-compile the Qt. And you need to stick this operating system. You can use, I was using virtual machine, but this virtual machine idea is okay, you can carry it, but it's a huge computer, at least a virtual computer. The size is huge. And it's not really portable. You can carry it with USB, or I'm not sure, but this is still not good. Then I come up an idea that we can use a Docker. With Docker, you can create host environment and a target environment. You don't need even a target to build Qt. It is the advantage. You don't need to install something. You don't need to install third-party libraries. You don't need to touch even hardware. So in this, for example, in this content, I'm not going to show you any real hardware like this. You will not touch it. You don't need to touch it. If you want to run the application, of course, you need to update your Raspberry Pi, your Jetson board. It's okay, your target. But to have these Qt binaries, this Qt cross-compiled Qt framework, you don't need the real hardware. That is the point. And everything is isolated. As long as you run the Docker and the QEMU with it, you can run these on Windows, on Linux, on I don't know, whichever operating system you want to use. It is isolated and efficient. And you can use it later too. You don't need to change something. You don't need to build it again. You don't need to touch it because it's an isolated image, isolated container. So you can find all the steps on this repository. It has been here for a while already. Some people already tried. They like it. They have some problems that we fixed. And I explained already here, step by step. You can read it. I really recommend you to read it also. First, that you will find here, there are some files like a Docker file rasp, Docker file app that I'm going to explain in this contents. And you need to install Docker. These steps can vary, the steps can be different according to your operating system. I used here Ubuntu 22 or 20, but the steps can be different for Windows, for example. The main idea also here, the important thing, when you install Docker, you need to be sure that you install the QEMU also with it. So QEMU system, this is for Linux, of course. So what we are going to do, we are going to emulate the Raspberry Pi or Jetson or ARM, the target environments on our host system with Docker. That's the point. Then we will have sysroot. So when you check, I just showed you right here, we need a sysroot for cross development. So from Docker container, we will copy the sysroot. Then we are able to use it later. We don't need to touch the hardware. We don't need to copy by hand. It is so simple. So I'm going to show you these steps. We are going to build the Docker, install Docker. But as I told you, the steps can be different according to your operating system. Then later, we are going to build Qt 6.8. We are going to try these commands. This is so simple. I'm going to show you. So don't be afraid when you see Docker here, guys. Don't be afraid, because I saw some people, they say, I just want to build the Qt. I just want to install the Qt. I don't want to touch Docker or something. I did this because it makes our life simpler. The Qt Docker makes our life simple. That is it. Before explaining these steps, let me show you here there are just Docker files. So what does it mean, these Docker files for you? In the beginning, I was thinking to create only one Docker file. So in this Docker file, I can switch between hardwares. I just experimented it and it didn't work because in the different hardwares and with the QEMU, it is not possible to switch them in the single Docker file. So what I did, first I created a simple Docker file rasp Docker file for Raspberry Pi. So it's simply ARM image from Debian. So this is Raspberry Pi operating system itself. So you can use it like that. You can use a Raspberry Pi operating system for like a virtual machine also as a virtual environment. So be careful, this is a 64-bit. So if you use it for like a 32-bit, then it will not work. So you have to be careful about it here. So if you want to use it, I never tried it also this one, but if you want to use for 32-bit, then you need to change it here. You need to update this one here. There are some commands, that we don't need to everything in the command line, so there should not be any kind of an interaction with the user. That's why it's just a Debian front end if there is something, because everything in the image. This will enable us, disable the user. There is in each Docker file, there are logging files. So you can also change the name or something. You can delete it. If there's a problem, you need this log file. This is the dependencies, right? So you can run this also on your targets later if you want. If you want to exact the same, if you want to match the target also. But it's not really needed. Like there are, if you update the probably Raspberry Pi, probably these will be there for you. So like OpenGL libraries, like X11 libraries, like the touchscreen libraries, these are needed for the Qt build process, for the development, for the dependencies. Then this lib, usr include, usr lib directories will be in this tar file. Later this tar file will be copied by hand and another Docker file will use it. Like if you search this here in this Docker file, see this is copied here and it will be used for the build process later. That's the point. So this Docker file is for ARM. This is used QEMU in the background. That's the idea. So you can run simple hello world applications, but you cannot run really hardware dependent things here, right? So this is Raspberry Pi. This is Raspberry Pi itself. The good point is this here. It will create some kind of an image, and there's a tar file. But later at the end, when you complete everything successfully, you don't need to keep them. You can delete them because you don't need it anymore. You can run again. It is simple. So from the size wise, So you can delete later, you know. It is also nice. For this is a quite huge file. You can divide it if you like, but I like to keep it, you know, as one. So this will create Debian image. So this is a good idea because they are same. So the Debian bookworm, this is for ARM, this is for Intel Debian bookworm. If you match the operating systems here for this Qt cross development, then you don't need to build toolchain yourself, because you can find simply the toolchains, the desired versions. The desired versions is easy to find in this case. So if you check the Raspberry Pi, you will see that these dependencies will match for the toolchain. So I never built right now in this content. Before I was building it. Now I don't need to build now because I have it already in the repository. If you change the version of this Debian, probably you cannot find it. Or if you use Ubuntu or something, because I was using before Ubuntu, I couldn't find test this approach. Now I use Debian, then it's so simple everything. You don't need to build a toolchain anymore. And for the Jetson also, you will see this is the same. This is a good approach. So still there are dependencies, right? But I'm sure that most of them are not needed really because it's a host environment. I just try to update the system as much as possible, you know, like up to some stable level. Still, it's non-interactive, means there is no user interaction, right? This is nothing more. These are important if you want to change the version or if you want to use the oldest kind of, I don't know, like an operating system for the targets, then you need to find the correct dependencies that you can find on the internet. It will create some kind of you can read line by line, but I don't want to go into details really. So they are just a build directory. So everything will be in this directory. And I could just create a sysroot, you know, for this tar file that I showed you from the another here, this Docker file for the Raspberry Pi. I built a CMake because I saw some bugs before. Maybe it's not needed now. I never tried. It's not needed maybe now. But it's a good idea to use the latest CMake. Then here in this case, here in this run content, I just built the Qt. So in this, here as you see, Qt base, Qt shader tools, Qt declarative modules are built. So if you want more modules, or if you want to use just only Qt everything, you know, in a single tar file, then you need to change a little bit maybe here, but the change will not be much. So I haven't tried yet. I couldn't find time, but I will check this too. But it's enough to build QML applications and most of the, you know, the Qt base, most of the Qt applications with it. So first host part will be built, you know, then here compile shader tools, declarative, and Qt base will build for Rasp. So there is a CMake in the same file, CMake for toolchain, because it's a cross development. So as you see here, this part is important if you want to change it later, because this is the target compiler version, GCC version. So this is 12 in this case, but according to the operating system, this can be different, you know, keep it in mind. And after this is host binary, this is Qt binaries. So I also have the host binaries, but it's not needed, we can remove it. So this one is Qt Pi binaries. This is the tar file. This tar file, if you have this tar file at the end and copy to Raspberry Pi, then you will have the Qt, that is it. It is so simple. It builds some example to check, you know, everything works or not. This is just a hello world example, that is it. And for Jetson, it is same. So if you check the repository, there is a Qt 6.8 for Jetson directory. Everything is inside this page. It is the same, idea is same. We'll install Docker and run some applications. There are a few small details that I'm going to explain it later. But if you check, for example, the Docker files here, Docker file for Jetson, you can see the same idea, just dependencies, and at the end it creates Jetson sysroot tar file. This is for sysroot. You can delete it again later at the end. But there are some kind of an arguments because the Jetson use Ubuntu, and you know the Ubuntu had different versions, and each different version can have different GCC version, toolchain version. But I never tried it. This is for 2004. You know, like I never tried 22, so I never tried the old GCC old 18 version. So if you try it, probably you can see problems or some kind of compatibility problems with the new Qt versions. I never checked it. So it is normal to see a problem. But if you follow this page, you will not see a problem for, I already built it. It is okay. But I just want you to know that there are arguments and there are different versions for the operating system. That is it. And if you check the Docker file for it, It's the same. There are some, I just echo it, there are just some arguments. And according to the arguments, it update the source file, then it install the dependencies. And GCC version is important again here, according to the version that you passed. Then build the CMake and simply install Qt tar files, Then build for the host, these are and host, and at the end here build for the Jetson board again with the toolchain file. It's quite same, and at the end it will give you the tar file. That is it. And if you have tar file, send it to Jetson board and untar it wherever you want. That is it, and you will have Qt. You can use this application, this approach. You can use this approach, for example, like in the Jenkins pipeline. If you have a Jenkins pipeline or kind of a pipeline that you want to build the image, then you can use this Docker approach and you can build everything, and you can add this tar files or whatever you want to do your image. Everything under your control. Everything will be under your control. It's so simple. So now let's check first how we can install Docker, right? Then let's check together how we can use this approach for Raspberry Pi and for Jetson, and discuss some details. This is my version, Ubuntu version, but this is not important, because as long as you have a Ubuntu, you have a Docker, then it's okay. You can use this on the Windows. Just first update the certificates like here, and you need to update the source file later to install Docker. These are for the security, mostly. And later we are going to install some dependencies for Docker. Then we are going to install the emulation, the QEMU dependencies for Docker itself. Then we are just trying to some kind of hello world applications. Then it is ready to go. This is like a command line interface, we are going to install. These are dependencies. Then you can run the hello world. If you see this example, hello world, hello from Docker, then it's all right. Then you can update the, permissions. If you don't want to use with the sudo every time, you can manage the Docker permissions. Then you can simply install dependencies for QEMU. So that's just a QEMU system. QEMU system, x86, QEMU KVM, libvirt, daemon system, kind of these dependencies. Simply, these are for mostly the emulation, hardware acceleration, And this is libvirt clients is important. It provides the tools to interact with the libvirt. It's a virtualization. Later, you need to enable the libvrtd as a kernel module. Then you can start it. And later you can update the user, permissions. If you see this list at the end, empty list, then it's okay. And you can run just to, just a setting up multi-architecture Docker builds. It's just a simple commands, just a copy paste, nothing more. Then at the end, later, you can create a buildx instance. This will be needed also. You can give some kind of a name. I gave just my build that I just found on the internet. There's it. And this one prepares the builder instance for multi-architecture builds. And you can later, verify the installation like Docker buildx ls commands. But if you see this already, it is all right. Then that means you build, everything is all right, correctly, you build it. So you are ready to go. First, we are going to create a Raspberry Pi image from a Docker 5 rasp. This is an image with this command, the buildx build. This is a QEMU will be used, emulation will be used, and the container will be created from this image, name with the temp arm. Later, we need to copy rasp-tar-gz, to the current directory. Then we are going to run the next Docker file. We don't need to give the name now, which is the x.8 image. And from this image, we are going to create the container. And from this container, we can copy the Hello Qt 6 application, which is built before. And we can check that it is ARM, it's all right, everything's all right. And we can copy the QtPy binary star.js file for later usage to send to Raspberry Pi. After some time, when you run these commands, it's so easy. After some time, like a couple of hours later, according to your hardware, at the end, you will see that the Hello Qt 6 is copied and created as boot for ARM, means it's successful. And at the end, as you see that also there is a QtPy binary star.js file. That is it. Then you are ready to use Qt. Let's try this. Let's try to see that this Qt is compiled, and let's send this tar file to Raspberry Pi first. And the Hello Qt 6 application. Let's try to run Hello World application. And if you let's connect with the SSH, or you can just directly go through a Raspberry Pi and try the steps there. It doesn't matter. It's up to you. I just connect to Raspberry Pi with SSH. Be sure that you have a Raspberry Pi IP address. Then untar files here. First, you need to create some kind of directory, or just, it's up to you. But I create a directory under USR local Qt6. So I'm going to extract everything there to keep it isolated also. Later I can change it later maybe. So with the tar command, you can simply untar it. With the tar command, you can simply untar it. qtpy binary *gs under this directory that you created. Don't forget to export later this directory. Then go to Raspberry Pi, or you can also try here. But if you export the path correctly, if you run the application, then you will see that hello world something. That means it's okay. It's working. For Jetson, there's another directory. Just go to this directory in the repository qt6.8 for Jetson. The steps are same, but the commands are quite different. So in the commands, there are some kind of an arguments. You need to give these arguments according to your need. You can find a table in the repository. So after this, you will create a like a container from this image. This is a ARM image, and you will copy the sysroot here. It will be used later again. And you need to create the normal image with x86 to build the Qt. And you will copy the hello Qt6. It's the same like Raspberry Pi, the same. And at the end, also you need to copy to the Qt binary star file, Qt Jetson binary star file. After a couple of hours later, it will give you the hello world binary. It will show you that it is built for ARM, and also Qt Jetson binary *gs file. That is it. It's so simple. If you copy this star file to the Jetson board, the one you have, I don't know which version, and if you extract it like before, like a Raspberry Pi, then you are able to use the Qt. That is it. Let's extract it. Let's send it to Jetson board. It's here, like Qt Jetson binary *gs with the SCP or FTP, whatever you have. This is my Jetson board. This is Jetson IP address. If you go to Jetson, you will see that it's here. I forget to send to binary, but it's okay. I can do it later. So I create again the directory until USR local Qt6. It's up to you. Untar it there or wherever you want according to your needs. Then let me copy hello world application again. I forgot it already. And export it. Don't forget export library. If you run the application, you will see that there's a QML page, window, whatever. If you click the button, it's just a simple dummy application. Then it shows it's working. That is it. It's so simple. It will take just time. You don't need to touch anything. As long as you have a Docker in your operating system, that is it. All dependencies will be handled, in the repository. You don't need to think about it. You don't need to think about something else. That is the point. So if there's a problem in the repository, if someone see that, I or someone else, will fix it and everything will be all right. So let's talk about now, what happens if you want to update for example, like a application, right? So in the repository, there is a Docker file app. So this will be used to compile your application, really. So we build some kind of an hello world application, right? Let's assume we want to change it. If you check the file, there is a Qt cross build is used. So Qt cross build is the image name that we created before. And this Docker file will create an image which inherits everything from this image, Qt cross build image, which has the Qt binaries, right? The cross compiled Qt binaries. And I just write here like it's not important really, like a directory names, but you can update accordingly. It compiles the hello world application. So I'm going to now update the hello world application, like here, like I don't know, like adding an extra line or kind of changing this hello world text, like there's a change or something, or there's a change. Then we need to recompile this, right? For Raspberry Pi, cross compilation. So using this Docker file app, we can simply compile it. As long as we have Qt cross build image. It's so simple, like a build Docker file app with a name final app, for example. And this will give us an image. You can see it's compiled now. And from this image, we can create a container, Docker create, like the name. So you can give just some kind of a name that I just gave, like a final app, from final temp app. Then from this temp app, you can copy the application. You need to know where is it simply, it's up to you. It is in the build and project file for me now. It's a hello Qt6. If you copy it here, then that is it. Then you have recompiled application that you just updated. If you check the file, I'm not going to run it. File Qt6, that you will see that it is created for run. So that is it. It's so simple. You don't need to install any third party or something. This is a Docker, and you can delete everything later. You don't need to keep them. You don't need to even target. You don't need to even real hardware to build the Qt. So this approach is not only for Qt, right? This approach can be used for any cross-development applications. Even if not for the hardware, I'm not talking about for the hardware. If you have different operating systems, and if you want to build something for another operating system, then you can use this application too. This approach too. So that is it. You know now how to build the Qt for Jetson, for Raspberry Pi. But this approach is not for only like a Qt cross-development, right? Now you know how to build something for cross development or for different operating systems with the Docker. It's so easy. You can also use VS Code to make everything, like automized. You can do this. There's a video, so I didn't do anything in this content, but there's a content I already created a long time ago. You can watch it. You will have the idea. Maybe there can be some kind of small updates. We can use this approach for different. So I saw that already some people start the repository. It's good, and I saw that some people already like the application, like the approach. So share this approach, share the video, share the content if you like, and also so other people can see it. I don't have time really to share these things. So if you have any questions, you can leave a comment, or you can use the repository, you can use the GitHub, you can leave there as an issue. Some people already did it, we fixed it. If you have any questions, any idea, you can also write it. Thanks for watching, and take care.